rectangles you're calculating, and I mean you could count the area, but if you're calculating it here, the left sum is going to be, let's go back to our three rectangles here, right? The left sum is this rectangle, which actually is at the top, and this rectangle, you don't like this, and this rectangle. So it's the height on the left-hand side, which is 8 times 2 plus, what is it going to be here? So it's this height times 2, this height times 2, and what's the third one here? I think I missed with one here, didn't I? Yeah, these are wrong. These two are wrong place, aren't they? This one right here, and this one. So it's that, 4.8. Okay, so we got 8 times 2, 7.2 times 2, and 4.8 times 2. You can do this two ways. You can say 8 times 2 plus 7.2 times 2 plus 4.8 times 2. Or you can be clever and say, what if I was to stack them all up together? Well, they all have a 2 in them here. You could factor out the 2, right? You could factor out the 2 and write it as 2 times what would be left here? 8.2 plus 7.2. It's not 8.2. What am I talking about? I see why you're confused now. It's just 8 times 2. Well, because my times sign, I'm being a little sloppy here. You could factor the 2. You could just do the times 2 once, right? If you multiplied it by 2 once, that would be the equivalent of doing this, actually, as a matter of fact. It would be like taking this and it can't cope with this. Oh, no.
Oh, no.
Attempt this again. If it crashes again, I'm sorry to tell you that, but look, now I can't even... Uh-oh. Now it's really messed it up. Okay. Can we move this? Yes, we can. Okay? Yes, we can. Yes, you're basically what you're doing there is you're stacking up it undid all my work here, right? But when it crashed, no, well, it doesn't. It's supposed to save as you go, except when it crashes. You can add them up and then multiply just as easily. I don't want to get hung up on all this, but the concept is what you're doing. If you did the right-hand sum, okay, if you did the right-hand sum, I don't want to dwell on this, but it's the rectangles on the other side, right? It would be too small, right? And we'd have this one. And then you'd have, wherever it touches there, this one. This one would be too small, or you can do the midpoint. How about if we just do this? Because I don't want to lose this. I don't want to lose the concept here, and there's all kinds of forces contributing to losing the concept. The left-hand sum is too big, right? The right-hand sum is too small. The midpoint sum, the midpoint sum is pretty good. It's not really just right. The trapezoid sum is pretty good, but it's not just right. Yeah, if you start with any one of these and you start increasing the number of subintervals, they all get better and better. If you did the limit as the number of subintervals approached infinity, so the limit as the number of subintervals approaches infinity, or the limit as the width of the subinterval approaches 0, they're all going to be the same.
Can we see it visually?
Well, we did this one. It doesn't matter which one you start with, right? Well, let's put them all there at the same time.
This is going to lag so bad.
This could lag. This is going to lag really bad.
That's probably going to blow the screen. Blue screen.
Well, it's having trouble. Oh, 190. I made it because it just gets ridiculous after 200. Trying to calculate it. It's calculating all this stuff, right? But you can see that they're all going to approach the same thing, right? That is the concept here, that whichever way you approximate it, it's going to it's really having trouble.
Restart.
Restart. Well, yes. What?
I think you should. It's a good
Okay. All of these are going to give you something. We could calculate. I think this one worked out to, what was it? 8 times 2 plus 7.2 times 2. Has anybody calculated that one? Plus 4.8.
Yeah, 40.
This one's 40. Too big. This one was the right hand sum. It was too small, right? It was basically, it was all of this stuff plus the small end of the thing, right? 7.2 times 2 plus 4.8 times 2 plus 0.8 times 2. It was, what did you say it was? 35?
No, it's 25.
It's got to be something smaller than the real number, right? 25.6.
Correct.
The midpoint sum works out pretty close. Did you do the midpoint sum?
Right now.
Oh.
You're just guessing? It's 34? Okay. The trapezoid sum we will do, because I would like you to know how to calculate this. First of all, the midpoint sum is just the rectangles in the middle. So it's basically just doing these three heights, the ones in the middle at 1, 3, and 5, right? You can add those three numbers, right? Remember stacking up the rectangles here? Just add those three rectangles and then multiply it by 2. 7.8 plus 6.2 plus 3. All of that added together times 2. Right? So we got 7 and 7, 14. 17 times 2, it should be 34, right? The midpoint one is 34. The trapezoid one I would like you to be able to do, just because you might be asked to do something with that, and I don't know if everybody's okay with seeing how to quickly find the area of 3 trapezoids. You want the average height. Okay, let's write the heights in here. We have 8 on this side. We have 7.2 on this side. We have 7.2 on this side of this one, and 4.8 on the side of this one, I think, and 4.8 on this one, and this side is 0.8. Do you see you have 3 trapezoids there?
Yes.
If you want to find the area of each of those, you got to do the average of these two, height-wise, times the width, plus the average of these two, times the width, plus the average of these two times the width. So let's write that out the long way. Well, we could, let's save all the could you questions for later. Whoops, divide by 2. Times the width, which is times 2. It just so happens that these match up, so let's not cancel them out right now. That's just a coincidence. Plus 7.2 plus, what was the other side? 4.8. Divide by 2 times 2 plus 4.8 plus 0.8. Divide by 2 times 2. What you could do is you could factor out this 1/2 here, right? This divided by 2 is because they're trapezoids and you're adding 2 heights and then taking the average, right? If you had to do a whole bunch of them and it wasn't a coincidence that these matched up here, your subinterval was the same as that, what you could do is factor out the 1/2 here, right? And you could factor out the other 2, and then you can just add up these things. Okay, you see what happens here? How many of the first one do I have here? I got 8 plus 7.2 plus 7.2 plus 4.8 plus 4.8, running out of space here, plus 0.8. The question that people always say is, well, how come you have 2 of these and only 1 of the other ones? Yeah, go back to the picture and look at it, right? One of the trapezoids has 1/8, but 2 of them, the middle ones all have, you're going to involve those twice. Okay? Anyways, you work that out, it becomes pretty good. The idea is which one looks the most accurate, you can answer that, but as the width of subintervals approaches 0, it doesn't matter. Okay? They will all be the same. If you do the limit, this is the key here. Okay? Limit, you missed your 10-minute mark there. We should stop this. Hang on, we have to really make sure this is the moral of the story, right? It was a long story that had a few breaks in it, but they will all be the same. Okay?